So, once Bill gets up here, we'll go ahead and get started. I realized I forgot to introduce myself in the last session. Oh well. Nobody needs to know who I am. Just a moderator.
Come on.
All right. Well, go Blue Team. Thank you guys for making it through to your last breakout room. Good job. Yes.
For all of us.
So this, yes, to everyone. So this breakout room is focusing on the laws and regulations around carbon management. And so to that end, we're going to talk through why we need laws around carbon management. And we are going to have each of our speakers here answer a few questions, give a little information about what they do and why. Hi, welcome. Yes, okay, good. Donna, I'm glad you made it. All right. So welcome to the Laws and Regulations one. So my name is Emma Crow-Willard, and I'm the managing producer and editorial director at Climate Now. And that means I kind of oversee all of our content operations. So I produce all of the videos that we create that are educational videos about climate solutions. I also oversee podcast production, videos and a podcast you can check out at climatenow.com. And then I also helped with the programming of this event, along with several other folks. So my background is in a mixture of science and communications. I started out as a planetary geologist. I mapped one of Saturn's moons. I went into hydrogeology around California, and I did that for about 3 years, drilling water wells and monitoring wells. And then I decided that we had a communication problem in science, not a data problem. And I decided to go into science communications. And that's how I found my way to Climate Now and here in this room today. And so with that, I want to have each of our speakers introduce themselves very briefly. And I'm going to first have Leslie go, and then we'll bring up Molly on the screen here, who is joining us virtually. She is from the EPA in DC. So go ahead, Leslie, and while we bring up Molly.
Okay. I'm Leslie Savage. I'm the Chief Geologist of the Railroad Commission of the Oil and Gas Division of the Railroad Commission of Texas. I'm spearheading the Commission's effort on gaining enforcement primacy for the Class 6 program. I'm glad to be here.
Great, thanks. Bill? Just a short introduction.
Trick because you said you were going to do Molly.
Oh, I'm sorry. I tricked you.
It's okay.
He was like, I don't have to do anything right now.
So I'm Bill Lowry, also known as William Lowry, but I work for the Pipeline and Hazardous Materials Safety Administration, which is part of the United States Department of Transportation. I want to mention our website. We have a lot of interesting stuff about carbon dioxide because we've had a couple of meetings this year that carbon dioxide was the topic of. One was a public meeting in May in Iowa. I had a lot of landowners there and a lot of interesting presentations, and it's all available for review on our public meetings website, as well as our R&D forum from a few weeks ago, where we had a team working on CO2 project recommendations. Also, we have a investigative report that from the investigation of the incident, CO2 incident in Satartia, Mississippi. Also, I want to mention that we are in the process of promulgating a new, enhancing our CO2 rules and regulations, and plan to have a notice of proposed rulemaking out early next year, and would encourage you to find that docket and comment.
Great. And that's going to be about CO2 pipelines specifically for.
We're putting together. We got a team putting together a CO2 specific rulemaking. A lot of it was because of Satartia, is how it kind of got instigated. We've been regulating CO2 pipelines for a number of years. Most of the CO2 pipelines we look at have been legacy EOR pipeline projects or pipelines in operation, as well as trying to take into account some of the comments from the public meetings and the information that we've collected in various venues such as this as well.
Great. So we'll go into more detail on that afterwards. So I'll go to you now, Molly. Welcome.
All right. Good afternoon, everyone. I'm sorry I'm not able to be there in person. My name is Molly McAvoy, and I work in the Underground Injection Control Program, or UIC program for short, within the U.S. Environmental Protection Agency headquarters office in Washington, D.C. Currently, I'm the UIC Direct Implementation Lead for our office, and one of the major roles, or one of the major activities of our team in headquarters is to support the EPA regions as they review permit applications for geologic sequestration or Class 6 wells. So today I plan on speaking to the role of the UIC Class 6 regulations and the role of our program in this space. Thanks.
Great. Thank you, Molly. All right, over to you, Ken.
Ken Mills, almost neglected to say, proud graduate of Sharpstown High School, just down Bissonnette. I am a lawyer. I am the director of the Oil, Gas, and Energy section at the Texas General Land Office, and our role here is we're not a regulatory agency, but we own huge amounts. I say we, the Permanent School Fund owns huge amounts of land and minerals, and so we're currently negotiating and have negotiated CO2 pore space sequestration leases.
Great.
Thank you. My name is Paige Powell. I'm a policy manager for Commission Shift. We're a statewide nonprofit organization that's a watchdog on the Railroad Commission of Texas, hoping to hold them to their mission. My background is in economics and public policy. I've spent more than 10 years in environmental advocacy, and I'm a native Houstonian.
All right. Awesome. You can hold on to that. All right, so now I'm going to pass it over to Molly to share a little bit about the underground injection control program and the regulations they have in place to try to ensure safety and environmental health.
Thank you. And I just need 1 second here to try to share my slides with you all.
Great.
Okay, confirming. Awesome. Okay, so as I mentioned, I'd like to talk about the Class 6 regulations from UIC, but first I wanted to get into where our program gets its authority from, and that is the Safe Drinking Water Act, or CIDWA, as I have it spelled out here on the slides. Safe Drinking Water Act was passed by Congress in 1974, later amended in 86 and 96, and it protects public health by regulating the nation's public drinking water supply, including both surface and groundwater sources. EPA is authorized by CIDWA to develop requirements and provisions for the underground injection control program. And this UIC program, the purpose of it is to protect underground sources of drinking water from contamination from the injection of fluids into the subsurface for disposal or storage. Underground sources of drinking water are aquifers that currently or in the future could be used as a source of drinking water. And some of the fluids that might be injected into a UIC well include things like stormwater, wastewater, brines from oil and gas industry, and compressed gases like carbon dioxide. So EPA has developed UIC program requirements that were designed to be adopted by states, territories, and tribes. Like many of EPA's programs, a state, tribe, or territory may apply for, and EPA may grant what is called primary enforcement responsibility, which we often call primacy. A state, territory, or tribe with UIC primacy would oversee the UIC program in that state, territory, or tribe. And when that does not happen, when they do not have primacy, EPA implements the program directly through one of its regional offices. Okay, there are 6 classes of wells within the UIC program. Class 6 wells are used for the injection of carbon dioxide for the purpose of geologic sequestration. The UIC regulations address the entire lifespan of a Class 6 project, beginning with site selection through construction, permitting of the well, injection, and site closure. The Class 6 requirements are designed to prevent the injected CO2 from moving out of the geologic formation into which it was injected, which in the figure I have on this slide is over a mile below the surface. And the regulations are designed to address the unique risks associated with CO2, such as the buoyancy of CO2 and its corrosive nature when it comes into contact with water. So there's specific requirements that address that. The regulations include multiple different types of safeguards that all work together. These include requirements to characterize and model the site to ensure that the geology will contain the CO2 that will be injected, the development of written project plans for several key components of the Class 6 project, including an emergency and remedial response plan, for example, and those would be based on EPA technical guidance. There's also an emphasis on keeping track of how the project is performing, including monitoring the CO2 plume and then the pressure front in the subsurface that's associated with that injection activity. So this slide depicts the life of a Class 6 permit. I won't go into all of the detail here, but it does cover the life of a project from the point where EPA receives a submitted application. Each Class 6 well requires a permit to construct and operate throughout the life of the site, all the way through site closure. Once EPA permit reviewers in our regional offices determine that an application is complete, they begin a rigorous technical review of permit application materials that have been submitted. And EPA will make a draft permitting decision after that review, which takes we have on our website approximately 18 months. There's a lot of variables in that, but it's a very rigorous review. And that's followed by a public comment period. EPA then considers all comments received during that time before making a final permitting decision. And if a final permit is issued for a Class 6 well and EPA authorizes injection of the CO2, well owners and operators would need to comply with permit conditions, which include testing and monitoring requirements, for example, among many others, while they are injecting the CO2, but also after they've stopped injecting CO2 during what we call the post-injection site care period. And that would be all the way through to the point where EPA approves site closure. And our regulations have a default post-injection site care period of 50 years that varies based on site-specific conditions. And then lastly, I wanted to highlight some of the work the program has been doing to incorporate additional environmental justice considerations into the program. In August of this year, EPA finalized an environmental justice guidance for UIC Class 6 permitting and primacy. The document outlines environmental justice considerations for UIC well owners and operators, as well as EPA staff. It also communicates EPA guidance to states, tribes, and territories that have UIC primacy. And one of the items that's emphasized in this guidance is the importance of early engagement with communities where these projects will potentially be located. In addition to that, as part of EPA's Class 6 Primacy Grant Program, which provides funds for states and tribes to develop and implement Class 6 programs, EPA included requirements for grantees that are designed to advance environmental justice in overburdened communities where those states are applying for primacy or have primacy. And so the QR code on the right of the slide, I'm pointing at, sorry, you can't see, that's not applicable, but on the right side of the slide that you're all able to see, there is a QR code where you can find a copy of that guidance document on EPA's website. Thank you.
Great. Thank you, Molly. All right. So with that, I want to take it over to Leslie, and I want to ask, so the EPA is permitting Class 6 wells and has this rigorous process, but then there's this option of primacy in which states can apply to try to take over that process essentially and permit Class 6 wells. Why is the Railroad Commission trying to get primacy for the state of Texas?
Okay, right now, actually, the state of Texas, the Texas legislature, basically told us to put it that way. They didn't put a time limit on it. They required us to adopt regulations and to seek primacy for the Class 6 program. There was little interest in 2009 when this was enacted by the Texas legislature. EPA adopted their rules, or they became effective in 2010. Our rules became effective, I think, 20 days before that. And then there was no interest for quite a while until the last couple, 3 or 4 years. Since 45Q and also some other public pressure, the need to have low carbon products.
And 45Q is a tax credit.
Yeah, and the 45Q tax
CO2.
credit. There's been quite a bit of interest in the Class 6 program. And so the Railroad Commission began preparing its application for primacy. We submitted the formal application to, or the governor submitted the application to EPA on December 19th, 2022. There were some amendments that were necessary to make sure that our regulations were met the minimum federal standards. And so we have adopted those regulations. We're currently updating our memorandum of agreement with EPA, which is a requirement for primacy, and also our program description, which is a narrative document that describes how we're going to administer and enforce the program. Also included in that, and kind of a new thing since North Dakota and Wyoming are the only two states that have a primacy for Class 6 right now. Louisiana's fairly close. But between the North Dakota and Wyoming and Louisiana and Texas, there were some additional requirements for consideration of environmental justice communities. And so we've been working through that. We've been taking a look at what Louisiana did. We've been taking a look at the guidance that's come out actually from EPA and from DOE and several other federal offices. And also a couple of years ago, the Commission created an Office of Public Engagement, which to me, having been at the Commission for 40 years, is revolutionary. We've always engaged, but we're not very good at engaging with the public. And so this group, I'm serious, with industry, with government, with whoever, and this group is going to make us better at engaging with the public. Do we have a question? Do we want to take questions? Or?
Yeah. Okay. Oh, great. Can you explain
I can
that
explain,
a little bit?
yeah. I am so sorry.
And repeat the question.
After having talked about this 3 times today, I apologize. Please call us on this. Enforcement primacy, basically, Congress set up the underground injection control program such that either EPA ran it or EPA could delegate basically to the states to run the program with EPA oversight. With respect to several of the class, the class 1, the class 6, which is what we're talking about, which is geologic storage of carbon dioxide, the state has to prove that its regulations and its programs meet the minimum federal requirements. And so their regulations have to be up to par. Their statutory requirements have to be up to par. Their enforcement authority has to be up to par. And basically, we submit that information to EPA along with a description of how we're going to administer and enforce the program. EPA has the decision as to whether or not to issue primacy to the state or to retain it for themselves. So that's what we're looking for. Basically, we want to run the program with EPA oversight, but it's up to EPA to tell us whether or not they think we have demonstrated that we are up to it. So I apologize for that. But anyway, the Office of Public Engagement, as I was mentioning before, we haven't been very good at engaging with the general public. We have a weird name that didn't have anything to do with railroads. And so what the Office of Public Engagement is doing is helping us to actively go out and talk to people, find out what their concerns are, find out what they want to know. And so it kind of has really blossomed with this Class 6 program because it has to. The Class 6 program has a very strong outreach element, environmental justice element, and so I frankly am really excited about it. I think that people are scared of what they don't know, and we just haven't done a lot to let people know what's going on. So I think that this will, we have another question, I'm sorry. I think this will help us.
Yeah, let me get you the mic here. We do want to be able to have some time for the breakouts as well.
I also want to just ask for clarity. Is the primacy only applying to these Class 6 titles, or does it apply to other permits?
The term primacy has to do with the underground injection control program under the Safe Drinking Water Act, and there are now 6 classes of wells. Class 6 is just the newest one, and a state can have primacy for any one or several or all of the classes of UIC well. I'm sorry.
So you guys are just applying for the Class 6.
We
right now.
already have primacy for the Class 2, which is injection associated with oil and gas. We have primacy for Class 3 Class 3 brine mining, and we have primacy for Class 5 geothermal and tar sands, which there aren't very many of. And this new category, Class 6, requires us to amend or revise our agreement with EPA to get primacy over that program. So I'm sorry, it's good.
Yes, good questions. Thank you. Okay, so with that, I want to, since we were talking about geologic storage of carbon dioxide, yeah. Go ahead. Oh, I wanted to pass it over to Ken, who, as he mentioned, they work in the whole pore storage space, and like who owns the land, who owns the pore space, who can benefit from leasing that pore space to put carbon dioxide underground. And so tell us first Ken, you said that the education fund, that's not the right name, I'm sorry.
I was just getting ready to answer your question.
Okay, owns a bunch of pore space, or leases a bunch of pore space. What is the education fund?
Well, yes, it isn't called that. It's the Permanent School Fund.
That's
It's
what it
created
is.
by the Texas Constitution in 1876. It exists to support K through 12 education in Texas. There's a permanent university fund, which is very similar, but it's different. It's for the universities. So the PSF, Permanent School Fund, was created, and along the way, this is well over 100 years ago, the legislature at the time put into it all the then unappropriated land in Texas. So, and not only uplands like we're on, but also all of the submerged land. So all of the Gulf of Mexico from the shore out 10 or 11 miles, the Three Marine League, belongs to the Permanent School Fund, both surface and minerals. Nobody knew what pore space was until 15 or 20 years ago, probably. So below ground, it seems like rock and thick sand formations if you drill deep enough. And that's where hydrocarbons are and other kinds of minerals that the mineral owner owns. But there are little teeny tiny holes, even in a tightly compacted sand geological formation. Those little holes are pores. That's the pore space, and that's what liquefied carbon dioxide. I just made up that. Liquefied carbon dioxide would be injected into, and that's the pore space. And while it's both the Texas Supreme Court and recently the legislature have confirmed that pore space belongs to the owner of the surface estate, unless it's been leased, unless it's been sold. So the Permanent School Fund, as the owner of the submerged surface of all that Gulf of Mexico land up and down the coast, owns the pore space, and we have leased and are continuing to lease that pore space in huge chunks for CO2 sequestration.
Okay, so through that you can get funding for education.
And just like any landlord or just like any owner, we are charging our lessees as much as possible. And that money all goes into the Permanent School Fund. It doesn't go to general revenue. It doesn't go anywhere but into the Permanent School Fund. You have a question, but I don't know if it's going to be a breakout type question. Here you go.
We can have some. That's why we have smaller rooms, so people feel comfortable asking questions.
How much onshore acreage does the Texas Land Office administer? I know y'all have the state waters, everything out to 12 miles from the coast, but how much onshore would you guess in terms of square miles or acreage?
I'm trying to visualize the map I have hanging in my office that has all those statistics on it. Our total mineral acreage is around 13 million acres. I think 8 plus is in the Gulf of Mexico, so that would leave roughly 5. Some of it is in, sections of land in West Texas. A lot of it is in the Trans-Pecos, thank goodness, in the Delaware Basin. But also the school fund owns all the minerals under navigable streams. So up and down the larger rivers, we don't own the bed, but we do own the minerals. So it's about, of just purely upland tracts, it's probably in the 3 to 4 million acre range, which sounds like a lot, but it's scattered.
Great. Yes. No, you hold on.
Okay.
Yes, Scott.
A question about how the land office decides how big of a tract to lease.
Sure.
And I'm curious, when you're deciding how large of an acreage you need, do you consider the potential of pressure interference among projects?
Absolutely, because these are not 100-acre leases or 1,000-acre leases. The one we have is 40,000 acres, which is 20, 30 square miles, something like that. And when we recently issued a series of requests for proposal to lease delineated tracts, I think the smaller ones were again around 40,000, and some of the tracts that were offered were more like 80,000 acres. Some of that was done with the help of consultants, geologists, geophysicists, who were able to help us just with areas that made sense. But a big part of the reason that those leases are so big is because the applicant for a Class 6 permit is going to have to demonstrate to the EPA where it thinks that plume is going to go, that pressure front, not only the CO2, but the salt water that it pushes out of place. And we want that contained to the extent possible within these lease lines, although we recognize that reality might cause us to have to amend those lines down the road. We own all the land, so it kind of doesn't matter. But we absolutely want to make sure they have plenty of room, that they're not interfering with anything else.
Great. So, so just to paint a picture of that, when you're injecting the CO2 underground and going a mile or more down underground, you're probably displacing whatever was down there in the pore space, and so there's a plume of pressure of whatever that displaced material is. And so you have to be able to demonstrate in order to inject, you have to be able to demonstrate how far out that plume is going to go, and you have to look for the different wells that are in that area and if any of them will intersect with that, and you have to be able to be leasing all of that pore space in which that pressure plume is going. Okay, great. So I want to pause because we want to be able to finish our talks here, and then we're going to do breakout rooms breakout groups, smaller groups, and each of the speakers are going to join one of those groups, and we'll talk through things there, just so that we can get done with time. So with that, Bill, we haven't come to you yet, so I want to just show your slides here, Bill, and to start off with, I wanted to ask, you said that you guys are putting together rulemaking on CO2 pipelines.
Yes.
For the purpose of pipeline safety and environmental health, I believe, something like that. That was started because there was this big pipeline. There was an
incident in Satarsha,
Yes.
Mississippi, that sickened a number of people, and there were truthfully some near fatalities.
And so what is different about the new, I know they're still being written, but what is being added? Because you've been overseeing CO2 pipelines for decades.
Yeah.
So what is different? What is new?
So typically the CO2 pipelines that we've audited in the past and looked at in the past have been in remote areas, typically used for enhanced oil recovery. Right now we're looking at about 5,300 miles of CO2. The one thing about the pipeline in Satarsha was that was not an older pipeline. That was built as a CO2 pipeline, and had only been in service for just several years, maybe 10. I don't remember exactly. But it was not an old pipeline. It was built, ostensibly to our regulations, which have been in effect since the 70s. It should not have happened. We fined the operator, sanctioned them, found that they had not properly considered the threat that actually took out the pipeline and caused the incident. So we typically in these regulations, and this is true of our other types of pipelines we looked at, we're toughening up the integrity rules, asking for more assessments and more sophisticated inspection methodologies and things, and also to incorporate more areas and do more extensive analysis to decide which places are high consequence areas. This wasn't what we call another populated area, so this qualified as a high consequence area. Should have been looked at. Should have been a threat that they detected and picked up on, and they missed it. So we try to. Unfortunately, a lot of our regulations they come from mandates from Congress, and those usually come from constituents that have been involved in some unfavorable occurrence such as that. And so we got a lot of directives in our most recent reauthorization, and that typically results in us having to make a rulemaking based on either an incident or such as this or some other. So that kind of instigated the rulemaking, and we've been working on it. We got a CO2 team that's working on the rulemaking. We hope to issue a notice of proposed rulemaking after the first of the year, hopefully in early 2024. Rulemaking takes time.
And what is it? What's going to be different?
Well, for one thing, we're going to address gaseous CO2 pipelines. They've not been a real large amount of those, but we anticipate that we'll need some rules for non-liquid CO2 pipelines, as well as the liquid CO2 pipeline rules that we've had for quite a while. We're looking at conversion to service. If an operator or a company wanted to repurpose an existing pipeline, what engineering would need to take place, what considerations, what analysis, what inspection, what testing, and so forth to successfully perform a conversion to service or a repurposing, since CO2 is a little different molecule than natural gas or a liquid hydrocarbon. So, and then, like I say, some tightening of the integrity rules, the identification of high consequence areas properly, and properly identifying your threats, consequences, and your risk, doing your risk analysis, and then doing your preventive, mitigative type measures. So
Great. So, one question on pipelines, and then I want to move over to Paige so she can give her presentation.
Hello. Last night I asked that anonymous question about the pipeline corrosion. So I wanted to narrow that question a little bit, given what you just informed us. In the risk assessments that are done,
Yes.
especially for newer infrastructure that's going to be created, is it considering the worst case possible scenarios of the next 100-year timeline? Like if in somewhere like here in in Texas or Louisiana next door, if the land starts going back into I forget the word.
Like subsiding?
Yes, subsiding, thank you. Or if there's a lot of sea level rise, more than we anticipate, and how could those events possibly be factored into those risk calculations?
well, it's a technical analysis that's going to have to be required, and if you're in a situation such as that, I mean, the regulations are basically designed so that it's incumbent upon the operator to know the specifics of their pipeline and design their integrity program to address those threats. So, we've tried to tighten up the regulations, but they're what we call performance-based regulations. So first they have to have their program, their procedures. We have to buy off on their program and procedures, and then they actually have to implement their program and procedures. And then we say, okay, show me the records. How are you doing this? And then that's how we do our inspections.
Great. All right. Thank you.
Clarification on that. The Society for Concerned Scientists came out with a report that actually showed where sea level rise was supposed to happen. Would you use that kind of source, or would you have to? It would be a source that was government generated to do the assessment that you're talking about.
Well, it would be, the requirement would be that the operator produce the sources or justify or prove up their analysis. So I wouldn't, sitting up here today, I wouldn't eliminate a source, but we would critically look at whatever data they were presenting to support their position that it was or was not in a hazardous location or a possible threat location.
Great. With that, I want to pass it over to Paige.
Yeah, I just wanted to note some of the other recommendations to PHMSA's rulemaking were like odorization requirements or crack arresters that would help prevent catastrophic events like the one that you see up here on the right. That was the Denbury rupture, which sent 50 people to the hospital, and some of whom are still experiencing long-term effects. The map on the left is from PHMSA's website. It's a heat map of hazardous liquid pipeline accidents, and you can see that Houston is the brightest spot. We do have the greatest density. We also have, as you mentioned, more subsidence, shifting land, and those sorts of things that are incompatible with rigid infrastructure. So we already see that natural gas and other hazardous pipeline leaks are pretty common. And with the proliferation and expansion of this infrastructure, we're likely to see more problems. Pipelines also get eminent domain, and this is a proposed build-out. I believe it was from a Princeton report. There was a McKinsey analysis of this, which showed that this full-scale infrastructure build-out would only capture 15% of the U.S. current greenhouse gas emissions. And folks in the Midwest are actively protesting the pipelines there. This is a picture on the left of some folks, I believe around Iowa, that were, not them in particular, but part of the movement that was able to stop the Navigator pipeline recently going through there. In Texas, there's no oversight of common carrier claims, and so protests for siting need to be handled through the courts. And in the state legislature last session, there was proposed legislation that would allow for the incorporation of land and mineral interests against the owner's will if there was a majority of ownership that was in favor of the project. So if you own a piece of land and your neighbors wanted to allow the project, but you didn't, you kind of like majority rules, and you're going to have to give up that pore space anyway. We're also really concerned about the Class 2 program in the state. CO2 EOR and wastewater disposal is causing induced seismicity, sinkholes, subsidence and uplift, well blowouts, etc. The image on the right here was an undocumented well that wasn't in the RRC database, and it was only found once it started blowing out in Crane County. And this is especially relevant to this Class 6 program because in order to mitigate seismicity in the subsurface, produced water can help manage pressure. Okay, I'm sorry, let me back that up. When you're injecting CO2 into a Class 6 formation, it can start to give you microseismic events, start to rumble, indicating that if you keep injecting, you're going to see problems. And so to manage the pressure in that well, you can produce some of the water, take it out to sort of reduce the pressure, but then you have to put that water somewhere. So produced water and wastewater disposal is going to be a vital part of the Class 6 program. And we currently have a wastewater crisis. That's not my word. I don't like to use the word crisis lightly. I do say that we have a climate crisis, but there was an article earlier this week in the Houston Chronicle about the produced water management issue in the Permian Basin. There was an earthquake just last week of magnitude 5.3, which is the second largest in the state's history. And for that reason, the volume of daily injection was significantly reduced to kind of manage those seismic events. And so operators are saying, well, now there's not enough places to put the water, so what do we do with it? Storage has other problems as it can cause well blowouts and things like that. We can see groundwater contamination, all of those fluids, brines, radionuclides, all of the other kind of lovely toxic substances can come up to the surface and get in the groundwater. The image on the right, you can see some really spraying fluids and a cow So I think, that's like, how's going to drink that groundwater, and like, what's in that groundwater, So this isn't just a risk to like people and land, but livestock and wildlife as well. And then, as is mentioned before, CO2, when it intersects with H2O, causes carbonic acid, which is highly corrosive to steel and cement. And so if it were to come into contact with a well casing, it could dissolve the well casing and provide an avenue for CO2 plume escape, releasing that CO2 into the atmosphere and reversing the benefits of storage. So this data was pulled from the RRC's website earlier this week. Texas has 7,800 orphan wells and 113,000 inactive wells. An orphan well does not have an owner on record. An inactive well does have an active owner, but they're not using the well, and they haven't plugged the well. The number represents the number of inactive wells greater than 12 months. Some of the wells on the list have been inactive for over 30 years. The Railroad Commission often grants plugging extensions over and over again. And all of those wells, are essentially leaking, methane, other kind of H2O, all kinds of gases. There's another type of well, P13, which we like to point to. A P13 well was an oil and gas well. It was drilled as an oil and gas well, but there were no hydrocarbons found, so then it was converted to a water well and transferred to the owner. And thereby, it's no longer under the jurisdiction of the Railroad Commission. It's now under the jurisdiction of the TCEQ, the Texas Commission on Environmental Quality. And the picture to the right is Lake Beamer, which is colloquially known as the Dead Sea of West Texas, which has been flowing for over 20 years. It's 3 times saltier than the ocean, and it's off-gassing, an article I read said, belching hydrogen sulfide, which has killed the occasional waterfowl. It's highly toxic and will kill you if you go there without any PPE. Lake Beamer, we believe, falls under the classification of an orphan well because it was drilled as an oil and gas well, and it's currently leaking oil and gas minerals, gases and things like that. But the state regulatory agencies have kind of, I like to say, calling it regulatory hot potato of like, not my baby, not my problem. And so this is just one example of what can happen when liabilities like orphan wells are not attended to in a timely manner. The older they get, the casings rot out, they deteriorate, and it becomes a more expensive problem to plug. And unplugged wells are at risk of activation, meaning that when you inject an increased subsurface pressure, those plumes, the CO2 plume and the pressure plume, are going to migrate into any available avenue. And so these offer a risk of CO2 escape as well as other nasty substances. So.
Great. Thank you, Paige. So that's a great example of why there needs to be a lot of oversight of these underground injection wells, and that's why they put together the Class 6 program specifically for carbon dioxide injection. And so I wonder, Molly, if you could tell us a little bit about what that program is doing to try to prevent some of the things that Paige mentioned, such as the CO2 contaminating groundwater or corroding existing wells.
Yeah, that is the potential risks that were highlighted are exactly why the Class 6 regulations were designed in the way that they were. So as it relates to Class 6 projects specifically, one of the requirements is for Class 6 permit applicants to, using computational modeling, outline where they predict the CO2 plume will migrate in the subsurface, as well as where the pressure front, it's been mentioned that the injection of the CO2 causes an increase in pressure in the subsurface and moves some of that salty water that's in that formation outward, and that causes increased pressure in the subsurface. So permit applicants are responsible for modeling that entire area. We call it the area of review, entire area where there is pressure influence from the injection activity. Within that area, they would need to identify any existing wells, such as abandoned and orphan wells, but also other wells that are not abandoned and are not orphaned, but that go deep enough that they could potentially interact with the injection zone or even the confining zones above above that injection zone that are meant to prevent any upward migration of that injected CO2. So if they must identify any potential risks there, and then they also must demonstrate that those existing, we call them artificial penetrations, that all those existing artificial penetrations will not cause migration upward. And if they could possibly cause migration upward, they need to do what we call corrective action. So they need to go in and mitigate those risks. So that can be re-entering that well, plugging a well that's abandoned in the area. If there is an existing well, regardless of whether it's in operation or abandoned, that is constructed of a material that is not compatible with CO2. We've mentioned CO2 in the presence of water is highly corrosive. If the construction materials of that existing well are not such that they're going to be compatible and they could potentially corrode when they come into contact, that needs to be mitigated, or that project would not be able to move forward. And that's what we call corrective action. I also wanted to address another important concern about induced seismicity. So when our permit reviewers permit application reviewers look at the application material and the site, they look at the seismic risk of the site, and then there is in what we call the emergency and remedial response plan, if not in the actual, it could also be in other places in the permit as well. That plan is enforceable, and we recommend and we have the ability to require that plan includes monitoring for induced seismicity. And in the ones that we have had to date, if there is any observed measured induced seismicity, well before it would ever be felt at the surface, they would need to stop or lower injection. So that would be what we would require, that they would have to, in some cases, at least reduce injection, if not stop injection until they can figure out what's going on, and they would not be able to proceed unless authorized to do so. So those are just some of the avenues that the Class 6 regulations take to address those risks.
Great, good to know. We have a very short amount of time, 5 minutes, to break into small groups and talk through some questions based on what you've learned here today. And so what I'm going to do is I'm going to say it'd be great if all of you guys maybe be a group, and then you guys right here can be a group. You guys in the back and in the back of this section be a group, and then everyone else on this end be a group. And we're going to have each of our speakers join one of the groups, and we're going to go through these questions. And so one is, what do you perceive as the biggest risk with regards to laws and regulations? Who should manage and how should that risk be managed? And are there gaps in carbon capture, transport, and storage regulation? What are they? All right, what did you guys talk about?
About CCUS.
Okay. All right. Whoop. All right, so I'm curious to hear from you guys what came out of your conversations in contemplating these questions. Any key points?
We didn't have much time to elaborate, but the question was, if you take a barrel of oil from the ground, you produce it, you consume it, you take the CO2 that you produce and you put it back in the ground, how much space is it going to take? If you take the oil out of the ground? Like we use a... Okay, so this is an interesting question. If you take 1 barrel of oil from the ground, you consume it as gasoline, jet fuel, whatever. You take all the CO2 that was generated and you put it back on the ground. How much space is it going to take? Is it going to take 1 barrel or more?
Okay, so that's a question for space underground. Is if you take oil out from under the ground, say you take a barrel of oil out, and then the CO2 that produces you put back under the ground, does that take up the same amount of space that the oil took up that you take out? Or does it take out a different amount of space? I don't know if anyone has the answer to that. Maybe Scott or Leslie.
It takes less.
Okay, CO2 takes less space than the oil took.
So just a little fact. If you burn 1 gallon of gasoline, you made 8 kilos of CO2.
Okay.
So you can do the math and see how much space does CO2 take underground when you compress it. Mm-hmm. But it generally takes less space. And we know that because we've been putting CO2 on the ground for probably 30 years now. Actually, no, 40 to 50 years. So we have a lot of engineering knowledge, how it's done, what you should do, what you should not do, and how you can actually make money out of it.
Oh, thank you. Did you guys have anything you wanted to share from your conversations? Sure. Oh, go for it.
Our group, we talked to the person who's in charge of the permanent fund for the schools. And so we discovered that there's a lot of information that we wish to know, but we cannot find out. And some of the things that we wanted to know about were, for example, like how is this money then distributed to the schools? And that's just by the legislature. How is this money then invested? That's by another group.
Yeah, it's complicated.
So it's so difficult to get a handle on what's really happening, and it doesn't seem to come down to the communities that live on the coast, for example, necessarily. You know, so it's hard for us to care about it deeply when everything is so dispersed, and it feels so out of our ability to handle it.
Yeah, so transparency of information, that's a big theme that's been coming up daily.
Nothing not transparent. It's just that
Hard to find.
that there 30 or 40 million people live in the state of Texas, and I am not the only person who works there, and so I don't know everything that the state government does.
Oh, yeah.
What I'm talking about is that we're experiencing a system of moral hazard in which people are making decisions that affect some people more than others, and that benefit some people who are not at all connected to the system of, and so it's a problem of this. Can we, the communities that live close to the places where things are happening and maybe are affected more, how do we actually get into the process? And we don't know because, again, he's not responsible for, when does the wildlife biologist get to get into the process to find out if there's going to be systemic environmental problems for all of the creatures that live in the ocean?
I'm just going to say that the lady from the EPA made a point of pointing out that there is an environmental justice and a community involvement. I know Paige has concerns about this as well, but as imperfect as it might be, there is specifically a process in place to engage communities where pipelines and facilities will be located.
I just wanted to respond as well. I mean, we heard a lot about community benefits plans and community benefits agreements and folks kind of reading over those. So that is probably going to be the place to engage. There are also community advisory boards, but I don't think that the permanent school fund is like the place to air your grievances. It's going to be more in the community benefits side of these projects.
Okay, great. So we're having everyone else join, and we're going to wrap up the whole program. So I think James from Climate Now is going to come give some reflections and next steps based on a lot of recurring themes and things that we've talked about throughout today and yesterday, and what the goals are to do with that information.